consultant with 3Cloud Solutions, and we're going to be talking about tabular data modeling. And we'll get into the weeds and talk about specifically what that means and what we're going to cover in the agenda. But let me go ahead and just do our introductions real quick. So just a little bit about me. First of all, you are welcome to connect with me if you have follow-up questions or you just want to follow me in the community. My contact information is here. You can contact me via LinkedIn, Twitter, or I see we have the Facebook icon next to my my blog there. I'd actually crafted a little bee, but apparently it didn't get copied. Anyway, that's my blog, and that's where I kind of do my brain dumps as I'm thinking about things and learning and sharing my experience. Been in the IT industry for about 25 years. I started out actually in the television news business in 1986. I was going to college pursuing a communications degree and got a job in a local newsroom, did TV production, worked in entertainment a little bit. And sometimes life turns you in another direction. I broke my foot, injured my foot in 1989, and I couldn't lug equipment around. And that led me to taking a job with a help desk with a small startup healthcare software company in Arizona. And it was a really good experience. I really enjoyed working with computers, technology, making things happen, and supporting customers. That kind of turned my career in a very different direction. And so I got into IT training and consulting, and eventually found business intelligence. That was the thing that really kind of got me thinking and helped me connect with data, with people, with solving business problems. And so I worked for a large consulting company where I did data warehouse design, worked with SQL Server reporting services, worked with Visual Basic, worked with a number of different Microsoft tools, fell in love with SQL Server analysis services, and worked in the BI stack for a very long time. In fact, I enjoyed that so much that I started writing about it, and that kind of sent me in the direction of writing technical books. And since that time, I've had the privilege to be involved in about 15 different technical books, either as the sole author or lead or co-author or just to be involved in tech writing and reviews and that kind of thing. Sometime later, I was invited to be part of the Microsoft MVP program, and it gives me the opportunity to connect with and work closely with Microsoft product teams, the folks that actually create these awesome tools. Worked with a number of different companies, one of which on a contractual basis, Pragmatic Works. Just really loved the culture and the people there. So I went to work for Pragmatic Works a few years ago. And last year, Pragmatic Works merged with and was acquired by 3Cloud Solutions. And same people, same stuff, we're doing the same thing. We're just a larger team. You'll notice that I left the year of that acquisition out there. I think we've all decided that last year is like the 13th floor of an elevator. We just won't mention it. Maybe it just won't be top of mind. But here we are in 2021, and just rocking it. All right. So what are we going to talk about? First of all, I will say this: if you have questions at all, and Crystal, I still don't see the questions window, but I do see the audience view now. So I may need some help with questions being relayed. But as you have questions, please chat them. And I will pause a couple different times within the presentation to answer questions and open this up for a little bit of discussion. So please don't be shy about asking questions. We're going to go in a couple of different directions, which includes we'll cover dimensional modeling basics very, very quickly. Now, I did a webinar early last year on the same topic, and this is kind of the evolution of that same subject matter. But there, we really went into the weeds and talked about the constructs of dimensional modeling. We're going to cover that very quickly, and we're going to move on. This is going to be a more advanced presentation, but I am using some of the same material and some of the same examples that have kind of evolved forward. We'll talk about the concept of filter propagation in a tabular model and the effects of single and bidirectional relationships as you're creating relationships within your data model. And then we'll also talk about scenarios where data model relationships may or may not solve business problems. So building a data model with relationships typically is kind of the bread and butter of a data model and a Power BI solution, but there are a lot of cases where we don't actually create relationships. And then we'll talk about creating dynamic measures that are built on a dimensional model. And I'm going to wrap up with a couple of demonstrations. One showing you a Gen 1 composite model using direct query with import mode. That's the current flavor of composite model capability. And then we're also going to take a peek at Gen 2 direct query using Power BI datasets, which is the next generation of composite model capabilities that is now in public preview and only has been for a couple of weeks now. Now, I just thought I'd do something really radical here and actually base all of my discussions, all of my examples, my demonstrations on this crazy idea of business requirements, meaning that we're going to kind of set a business requirement or a business problem context, and we'll talk about how that would be solved through dimensional modeling and design. And I'm going to introduce all of these topics, so I won't take a lot of time with them now, but we'll show products that are purchased by a customer. Within a dimensional model, we're going to display specific measure variations or metric variations side by side for comparison, things like current period, month to date, year to date, same period last year, fiscal period, things like that. I'm going to show a sales summary information for customers at a summary level. And then we also want to be able to see details for a selected customer drawn directly out of the database rather than caching that data in the import-only data model. And then we're going to, like I said, I'm not going to take a lot of time with these last bullet points, but these are the business requirements and the business problems that we're going to address through examples and demonstrations. Okay. So we did the poll. I set this up before Crystal was so kind to set up the polling questions for me. So I just wanted to kind of point out that regardless of where you are in your journey, whether you're a novice, you have moderate level or intermediate level experience, or if you're an expert, there's always something to learn. I don't know everything. I spend a lot of time with these tools. I give it a lot of attention and a lot of brain power. But the Power BI platform is huge, and nobody knows everything about it now, and it's a constantly evolving and constantly growing platform. And so if you're a novice, you're going to see some things that you may not necessarily understand entirely or may not be able to turn around and reproduce, but at least you'll know what's possible. And then as your journey continues, those are things that you may do. Within your role, and most of you said that you're in the role of a business data analyst. That tells me that you're hands-on solving business problems rather than perhaps being in an IT developer role where you're accustomed to a business systems analyst writing up requirements, then hands you the requirements, you develop something, and then we throw it back over the wall to the business. Some of you are in that role. And that's kind of a little bit of been a kind of a tug of war in the industry. We in IT want to maintain control. We need to have an eye for security and governance and central control, where the business just wants to do it themselves. And there is a balance there, and it can be achieved in different business environments. But your perspective might be a little bit different based on your role and how you work. All right, let's get to it. So we're going to start just by briefly talking about model schemas. Now, what do we mean by that? Well, a schema in this context means the way that we construct data, the way that we organize data within a data model. And categorically, in general strokes, there are really three different ways that I think about modeling analytic data. The first is the flat model. If you come from the business world and you're accustomed to using Microsoft Excel to do most of your reporting and data analysis, then you're accustomed to taking data and pounding it into a two-dimensional shape. And that's a good thing. That can solve a lot of business problems. It can take a complex world and simplify it so that we can make sense out of it. And that makes sense in certain scenarios and up to a certain level of complexity. Coming from the database world, we often think of relationships as being kind of a master detail relationship. So we see this with things like orders and order details, with invoices and line items. So this is a very common metaphor, and it's very necessary when you're dealing with certain types of data. There's room for all of this within dimensional model design. And then we have the pure dimensional model. And you could argue that a dimensional model is kind of based on these other concepts. Our dimension tables and perhaps even our fact tables could have been flattened from multiple sources, or at least they could have been massaged and pounded into a two-dimensional shape. And there's a lot of truth to that. The relationship between certain tables might be kind of master detail, but that's an arguable point. The dimensional model really is the foundation for analytic reporting, and it is the mindset upon which Microsoft have developed most of their business intelligence and analytical reporting tools. And that's not to say that, you know, they really kind of chose to embrace the dimensional model and necessarily constricted their products so they can only work with a dimensional model. I see dimensional modeling as kind of a materialization of the laws of physics. It just simply means that data in its most optimal state for reporting, and when I say reporting, I mean analytic reporting, summarizing, aggregating, grouping, and filtering. The dimensional model really is the result of that effort. So we can also, in the business world, we often use the term lookup table rather than dimension table, just to say, you know, we've got a table of customers, so we go look up a customer, we look up a product, or we look up a store. And then the fact is the actual metrics, the numeric values that we aggregate against those things. How many sales? What were the total sales? What was total sales quantity for a customer? By customer, we're going to sum up quantities. And so the materialized view of a dimensional model may look something like this. All right, that's about all we're going to do as we talk about these concepts, and now we're going to move forward. So business requirement number one, show products purchased by a customer. Now, that seems like a pretty simple request, but let's turn this business requirement into a technical requirement now, which means that now we put on our technical hat. We're going to articulate this requirement in technical terms and say, all right, well, what we really want to do, if we want to show products for a customer, we want to filter the products lookup table for selected customers, let's say a selected customer, through the sales fact table. So those customers who have purchased products, we want to see those products. All right, how are we going to do that? Well, that brings us to the topic of bidirectional filters and many-to-many relationships. So here's a simple example of a schema, a fragment of a model that might be used to answer this question. We have a customer table, that's a lookup or dimension table. We have a product lookup or dimension table, and those are related to this sales fact table. Now notice the cardinality of the relationship. Cardinality meaning how many records are related to the related records in another table. In this case, it's a one-to-many relationship. That's pretty typical. A sale can only occur for a particular customer. So as we go from sales to customer, we end up with one over here, but a customer can have multiple sales. So that's one to many. Now look at the directionality of the relationship. This is the filter direction for this relationship. Notice that it points from the one to the many. That is a natural one-to-many relationship, and this is considered to be fairly normal. Can we achieve this result by saying, all right, I'm going to select a customer, filter the customer table down to one customer. That's going to propagate the filter to the sales table. So let's say we have 50 sales So for those 50 sales, can I get a filtered view of the product table using these relationships? And the answer is no, you can't, because of the direction of this arrow. All right, let's take a look at one way that we could fix that problem. This is not the only way to achieve this requirement, but it is an easy way to achieve the requirement, and that is to change the filter direction on this relationship to be bi-directional. And that means that now we can filter the product table from the sales table. Well, why wouldn't you just want to do that all the time? Obviously, it gives you more functionality because it's inefficient, because it takes more time and it creates more headroom within the data model. So if we took a look at the properties of that relationship, if you edit that relationship, you can see that here you can control the cardinality, and here you can control what's called the cross-filter direction or the relationship direction. I would just change that to both, and that results in achieving this particular requirement. Okay, now that's not the end all be all. That doesn't mean that that's always the right thing to do. All right, next requirement, display specified metric variations side by side for comparison. All right, so again, I'm sitting in a conference room with business stakeholders, and we're whiteboarding a solution. I'm saying, all right, what are our requirements? And this is what a business leader is likely to say. I want to see specified metric variations, things like month to date, year to date, same period last year, fiscal period to date or fiscal month to date, et cetera. And I want to be able to say, all right, well, for this customer, for this date, this is how much they purchased, this was their month to date, this was their year to date, this was the fiscal roll up, this is the 3-month rolling average, et cetera. All right, a technical requirement might be select and show applicable time series measures driven by a dynamic user selection. Or matrix column group. So I'm thinking about how am I going to visualize this? In a 2-dimensional space, we want to see dates down here on the y-axis, and then for each column, for a date, I want to see the amount for that date. I want to see the month-to-date roll-up for that date, the year-to-date roll-up, et cetera, et cetera. So how are we going to achieve that? Well, really the conventional approach is to create a table that allows me to select a period. Now, I'm going to create a measure for every one of these variations. I'll create a current measure. I'll create a month-to-date measure, a year-to-date measure. These are really just variations of the measure. So the first thing I'll do is I would create a measure called store sales quantity. And then I could use that to do my month to date, my year to date, et cetera. And there are either DAX functions that make that very simple, or we can use some DAX logic to explicitly do things like, matching fiscal periods and that kind of thing. And I'll show you this example now. All right, so let me pull, I've got a few models open. That's this one right here. So the first thing that we'll take a look at, I'm going to actually make a copy of this matrix, and I'll come over to this one. Let's plot this one down right here. And I'm just going to simplify things a little bit. All right. So in this matrix visual, you can see that I have a date on the y-axis. So there are my dates right there. And I've created some simple measures. And the most simple measure right here is online sales quantity. Let's zoom in on that. You can see that online sales quantity is really, really simple. What we're saying is for however I am grouping an attribute, in this case date, within the context of that filter, of that date, of that customer, of that product, within the context of that thing, I want to sum up the quantity in the online sales table. Really simple stuff. Okay, so let's go ahead and plop that into my matrix. All right, now we want to see the month to date. So my online sales quantity month to date just uses the same measure. And here we're using the total MTD DAX function. And I'm just saying for a date, apply the total month to date DAX function, do the roll up for me utilizing the online sales quantity. All right, that's simple stuff. Let's add that one. Let's jump down to our fiscal period, which is a little more complex because I don't have built-in DAX functions to handle fiscal periods because different organizations use different methods for their fiscal reporting. We have to have a fiscal month number and a fiscal year within our date table. So you can see here in the order date table, I have a fiscal year and a fiscal month number. So here I'm working a little bit harder, but really this is what's going on internally inside my time series DAX functions. So what we're saying is looking at all of the order dates for the particular date that I'm on. So for a particular row, match the fiscal year. Give me everything that has the same fiscal year. Give me everything that has the same fiscal number. And then only give me those records that are less than or equal to the date that I'm on. And that's going to give me that month to date roll up. Let's call it period to date roll up because this is fiscal. All right, we'll go ahead and add that one. And so you can see that I'm going to get different values in each of these columns now. And it's exactly what I wanted, but I wanted to take it a little further than that. I'd like to make this dynamic. So now that I have these measures, I can create another measure called online sales quantity selected period. That's going to utilize a disconnected table that I've created called select measure period. Let's take a look at that table. So I actually just used the enter data feature and I just typed these values into a table. You could put this in an Excel spreadsheet. You could populate a table in your, in your data warehouse. Doesn't really matter. You just need a list of values. And then based on those list of values, my user can either select one in a slicer or we could group by it. And that will create this dynamic behavior. So I use the selected value function right here to essentially say, if there is a single value in context, what is it? If it's current, then return the online sales quantity. If it's month to date, then we're just playing a shell game with those measures that we've already created. Now, what can I do with that? Well, one, I could just allow the user to select something from a slicer. So let's go clear our slicer up here. Wait for that to catch up. And you can see that when you're writing more complex DAX, that it is going to slow things down a little bit. That's important to note. There's always a trade-off. So if the value is current, it's going to return the current value. So that should be the same as this. If it's month to date, it's going to return the month to date value, etc. But then I can take that one step farther, delete that matrix, come over here, and then we'll group this matrix using that period field right here from the selected measure period field. So this gives me complete dynamic capability. Now, the next step in a large model with multiple fact tables might be to use a new capability called calculation groups. Now, I thought, it'd be cool to do a quick demo on calculation groups. And as I worked through that, I came to the realization that there is no quick demo on calculation groups because it's a fairly complex feature. If you are building large, durable, formal Power BI projects where you have multiple fact tables where you'd want to do this kind of thing, look into calculation groups. You'll probably spend some time on the Italian site, SQL BI. listening to Marco and Alberto talk about these things. It's not trivial, it's a bit of work, but there's a lot of flexibility in there. All right, so at this point, let me pause and ask if there are any questions. And I see, will there be a downloadable video at the end? Crystal, you can confirm this, but I believe that the answer is no.
Not a downloadable video, but I'm sorry, can't talk today.
It's
Not
all right.
a downloadable video, but you guys can view any of the webinars on our YouTube page, and you guys will have the link to that in your email box tomorrow. So
I think that's a conditional yes. Then you can go back and repeat this presentation. It's just streaming. You don't download the file. Okay, awesome. Well, if there are more questions, please feel free to ask. Okay, next business requirement: show the number of pending orders in the order pipeline by day for a period of time. Now, I can tell you that as a consultant, I've sat in a lot of initial meetings with stakeholders where I say, all right, tell me what you want. What are your requirements? And, you know, we usually have to talk through these things. You know, I tried to articulate, you know, what my goal was here. And as I read this, I'm thinking, I'm going to have to explain this to somebody. All right, but let's turn this into a technical requirement. So by day, and you know, let's say that we're running a company, you know, that's like Amazon, you know, with customers who do online ordering, and you know, they want their stuff. You know, my wife gave me a really nice telescope for Christmas. It was just before the big convergence event, and we actually went down to Arizona to see the event where the skies were clear, and that was awesome, but I needed some new lenses, and I'm still waiting for those lenses. So I've got telescope lenses that are ordered and have not been delivered yet. I'm just chomping at the bit to get you know, my telescope lenses, so that if there's ever a non-cloudy day here in Washington State, that I can gaze at the stars again. So stuff that's ordered that hasn't been delivered yet by day. You know, how would we visualize that? Well, you know, that's immaterial. We could visualize it a number of different ways. We're going to do that in a column chart so we can see it trended. All right, here's the technical translation of that requirement. Over a selected range of dates, visualize the daily number of sales. So by day, for a specific day, I want to see the number of sales orders where that date on the chart is between the order date and the delivery date. And I'll also add that if the order has not yet been delivered, which means it doesn't have a delivery date, we also want to count that, because that's also a pending order. All right, so how will we do that? Here's the visualization. So I want to be able to select a range of dates. I can do that with this date range slicer here. And then here's a visual. We could use a line visual or an area chart visual as well. But in this column chart, we see one column per date. So for a particular date, in this case, let's see, it looks like I'm pointing to November 12th, 2009. So for that date, I want to know how many orders have an order date that's before that date and the delivery date that is after that date, or there's no delivery date. Okay, so how would we do that? Again, I would use a disconnected table. So we go back to our data model. You can see that I have a table called select effective date. And this was actually derived from my standard date dimension table. Here you see I have an order date table. I chose to do this in Power Query, but it could be done in DAX as well. But in Power Query, I'm only importing or creating the date table once, but then I have a number of reference tables. So an order date table is just a list of dates. And then for each date, we have the year, the quarter, the month, the fiscal period, etc. Same thing for the due date, same thing for the delivery date. These are exact copies of these tables, what we would call role-playing dimensions. And I created yet another role-playing dimension down here that just has that date column. And that's it. It's just a table for which we can select or group by dates. So let's go back and take a look at the actual report. So I had a column chart. And that column chart is grouped by the date column from the select effective date table. Again, an unrelated table. It's just a table floating out in space within my data model. Then I create a measure called online orders pending delivery. And I wrote a little bit of DAX. So let's just dissect this a little bit. So what we're saying is, first of all, this is only going to work in the context of having one date. If I don't have one date, then I just use the min function here. I could easily use the selected value function, which is probably a little more appropriate. But if I don't have one date selected, then I'm going to get the first available date, the first date that's in context. And so now I have one date within my chart here, and we're going to say, all right, count all the rows in the online sales table, because one row is an order. For all of the records in the online sales table, I want to filter those where the order date is less than or equal to the selected date, and the delivery date is greater than the chosen date, or, that's the double pipe, the delivery date is blank. Okay, so essentially I took my business requirement, my technical requirements, and I translated them into DAX. Let's see if it works. So there, you see the effect of that min function here. So 928 should be the same as this guy right here. It is. Now I can use my range slicer, and you'll see the number of columns change, and you can see that I run out of data on a certain day. That's why I used the range that I did. But now we can see that on any given date, I've got about 1,000 orders that are pending, customers that are sitting there waiting for their orders to be fulfilled. I've used this pattern in a number of production projects. One was insurance claims. It's important for insurance adjusters to know how many claims they have that are open. The claim has been filed, hasn't been closed, therefore it's on the books, and that's a financial liability for the insurance company. They want to get those insurance claims closed. All right, PowerPoint, where are you? There you are. All righty. Okay, so far you've seen some exceptions to relationships. So I'll make this point. I think it's very important that when building a Power BI solution or a tabular model solution, that getting the relationships correct is the most important thing. That's level 100, maybe level 200. To figure out what your fact tables are, your dimension tables are, maybe some many-to-many bridging tables, to get all those keys wired up and get that model created correctly. Then when you step back and you have requirements like the one that we just talked about, you can say, okay, well, it might make sense to work outside of relationships to fulfill that particular requirement. I'm going to show you an extreme example. So in this example, I'm going to show you this report. When we say, I want to see the store sales geographically, I want to see store sales by country or state or province or by city. What do we mean by store sales geography? So let's think about it. I'm going to jump back over to the same data set we were just looking at, and let's take a look at this data model. So you can see that here's store sales. This is my fact table. There's my store. Okay, and I need to go back to a larger view and zoom in here. There's store sales Okay, but then we also have customer, and I'm sorry, we need to look at online sales. You know what? Let's apply this to online sales. So an online sale can be fulfilled through a store, and we know the location of that store because there is a geography key for a store. I know that that's hard to see, so let me zoom in on it. There is a geography key, which means that we know the geography for a store, and we know the geography for a customer. But the problem is that we can't have a relationship from geography to store and from geography to customer if they're both related to the same fact table. And therein we have a problem. All right, so let's go back to our report. I just realized that I put the store sales report screenshot onto my slide, and I think I meant, well, no. Yeah, I did it right. Okay, I did it right. All right. So because we have an ambiguous relationship, meaning that we cannot get from store to geography through a relationship. And there are many reasons why you may not be able to wire up relationships between tables. That doesn't mean that we can't perform calculations that would emulate a relationship. And that's what this DAX measure is doing. So what we're saying here is that although there isn't a direct relationship from store to geography, there's no way to propagate a filter from store to geography, I can emulate that by using the treat as function. And there are a number of different ways to do this. I did a blog post recently where I was talking about this technique, and it reminded me of it was about 4 or 5 years ago. I was at the PASS Summit in Seattle, and an attendee came up and had a problem kind of like this. And I was trying to work through it. I was a little puzzled, and Chris Webb, who was a very well-known MVP, now he's now on the Microsoft CAT team for Power BI, came by and I said, hey, Chris, help us out with this. We spent an hour and a half. We were writing cross filter functions and summarize functions and filter table functions. And this was before the treat as function became available in DAX. So what treat as does is it essentially says, go get the geography keys that are in context. So if this table is filtered, in other words, here you can see I have a map, and so we know what a country is. So for a particular country, go get all of the geography keys and put those into an in-memory table. That's what, sorry, that didn't do what I wanted to do. Put that into a table using the values function, and then take that table of geography keys and cast it onto the geography key of the store table and filter this table, and then apply the calculate, in this case, the sum of quantity against the filtered keys in store. It emulates a relationship. It's a very, very elegant way to do that, and you can see that it just works. Okay? So let me take this just one step further, and this is actually my next slide. Yeah, so the store sales geography could mean the customer's location, or it could mean the store location, and just in code, we're going to decide what that means. In this case, it was the store location. All right, so are relationships always necessary? And the answer is no. And you've already seen the technique, but we could take that same technique and we could apply it even in a more extreme way. Just want to do a quick time check here. And I'm just going to show this to you real quick because I don't want to run out of time. I've got some really cool stuff I want to show you. So I'm going to jump over to this data model. You can see I only have one report page. This is a variation of the same data. Here we have online sales grouped by product category in this ring chart, here grouped by subcategory in this bar chart. Here it is by date in this line chart. Suffice it to say that I am calculating online sales quantity and a number of different time series variations grouped by a bunch of different stuff. And so if I were to show this to you and say, how is this done? You might say, well, that's easy. You just created a dimensional model. Your online sales fact table is related to your product table, your customer table, your order date table, piece of cake. That's just the way to do it, right? And the answer is wrong. I have no relationships at all, except for one out here to a little snowflake relationship between customer and geography. But other than that, I have no relationships whatsoever in this data model. And that works for the same reason that I showed you earlier. I'm just repeating the pattern using that treat as function to essentially build my own relationships on the fly. Now, is this preferable? Is this the right way to do it? If we had more time, what I would do is I would show you in DAX Studio, we would run a similar query in the model with all of the relationships and then run this one. And what you would see is that this measure spends all of its time in the formula engine, and other measures would spend more of their time in the storage engine. The storage engine is always faster because it is retrieving materialized values directly out of the dimensional model. Now, in this case, where I only have a few tens of thousands of fact rows, the performance is negligible and it really doesn't matter. But when you start compounding these things, when you start adding more complexity on top of these measures and layers, things are going to slow down. So always err on the side of doing things most efficiently as long as it meets your business requirements. Okay. Relationships provide a standard behavior. You always know how things are going to behave. They're going to give you optimal performance when you use standard relationships, one to many, two, and single direction. That is going to give you the best possible outcome when you use standard relationships in that way. Okay. Let's step off and talk about composite models and direct query. Now, if you're new to Power BI, I will say this, that what I've shown you so far might be the ending point for you. That it might meet all of your needs and you don't need to learn anymore. However, if you work in an environment where you have, let's say, a large system of record with billions and billions of rows, and you need to get data out of that system without aggregating and summarizing it, but it's just too much to shove into an in-memory data model, then direct query might be your friend. Direct query is not a good de facto answer, typically for analytic reporting, because it can be slower. But let's step back and talk about this requirement. Show sales summary information for many customers. So if I'm grouping those customers by region or geography in some way, I want to see those customers at an aggregate level with only specific information. But then for a specific customer, I want to see the up-to-date record without having to refresh my data model. Here's the technical requirement. Using a composite model in memory and direct query, cache report summary information for improved performance. That's the summary level for my customers, and look up customer details using a live connection, going back to the data source. So we have import mode, we have direct query. So import mode is native to the modeling engine. It uses the Vertex storage engine. Everything gets shoved into memory, it gets compressed. If the model is designed correctly, and if your data has the right characteristics, it can be extremely efficient. Data can get compressed to, I've seen compression rates of up to 50 times, 1 to 50. 1 to 20 is more typical. 1 to 10 might be typical of like text data that doesn't compress quite as well. But it requires memory. And that's okay. And we can have tens of millions or up to billions of rows loaded into memory, but it is cached and you have to refresh that cache. Direct query, by contrast, requires no in-memory storage whatsoever because you're not storing the data. You're going down to the source every time a user clicks on or interacts with a report. So it utilizes the data storage query engine. Now, if you're a DBA or you come from a relational database background, you might think, well, that's the way to do it because it uses the stuff I know. The data is live, but it limits, there's certain DAX functions that won't work well, won't perform well, and it's typically going to be slower. So, it's a whole trade-off scenario, and we're going to take a look at. The reason that some of my demos are a little slow is, one, I'm screen sharing, and two is I have 3 of them open. So I'm going to jump over to close the one that I don't need. I don't need that one. And I don't need to save it. All right. So here is my customer sales summary page where I see certain measures organized by regions, and I can actually see the customers, but I only have a few fields available to me for each of these customers. Now, let's take a look at the data model so you can see where we're going here. So I have 2 versions of my customer table in this model. One is a summarized customer table. This is import mode. Here in the new model diagrammer, you can see that there is no colored bar at the top of this table, which tells me that it's an in-memory import table. And here I have my customer detail table. And this was connected using direct query to my SQL Server database. So I do have a live connection to my SQL Server database. When I deploy this model up to the service, that connection would be facilitated through a gateway. But that blue bar suggests that this is a direct query table. And you can see that there's a one-to-one relationship. And yes, I've created a bi-directional filter because that meets my needs, and I'm willing to kind of accept the performance hit that might cause. So now that I have a relationship between those 2 tables, let's go back to the report, and you'll see that, let's say I want to go down to Berlin. So I'm looking at my customers in Berlin, and let's go down and let's see who have purchased the most products. So Christy has purchased a lot of products. You can see that I have another report page here that actually uses that other table. So I'm going to right click and I'm going to drill through from this page to the other page. Now it's not screaming fast, but it is actually running a SQL query against that other database, and I'm now looking at details that aren't available in my summarized table. And I could add all kinds of details here. And you can see that when that was last updated, etc. Now I want to keep moving because I've got one more important thing to show you, and we only have 5 minutes left. So I will ask you if there are questions about that, and we can queue those up. But as of the December build of Power BI Desktop, we now have a capability that is a little hard to describe in terms of how impactful it actually is. And this is the ability now to create direct query connections to published Power BI data sets. And you can bring in as many different connections as you want into a local data model. I'm just going to get started very quickly to show you how you would do this. We don't have time to explore the entire feature, but then I'll switch over to an existing model. I'm going to close this one while we're waiting. Now, while we're waiting for that to open, I will just take you out to my Power BI tenant and show you that I have a data set out here that's based on internet sales only. Let's say that was built over a period of months and it was tested and it's in production and everybody's using it. We've got hundreds of users using it. You know, the CEO checks the, you know, a report once a week. There is no way that we are going to upset that project. We're not going to go make any design changes to it because it's in production. Okay, I also have a store sales project out here. So a separate data set, separate data model with its own reports, and that's in production as well. Now the requirement comes down that we would like to combine internet sales with store sales, but we don't want to start all over again. We've already done that work. Why can't we leverage the work that we've already done? And you now can do that. So I'm going to choose Get Data. And eventually we'll have the Get Data dialog open up, and I'm going to say I want to connect to a Power BI data set. Okay, so and eventually that's going to open up a dialog and prompt me to go to a workspace and then select a data set. Since we're a little short on time, I'm going to shortcut this just a little bit by taking you to my blog, because I just barely did a blog post on this, just doing a first look at Generation 2 composite models with live Power BI data sets. So it is a feature that it's a preview feature, so you need to turn it on in Power BI Desktop. And when you connect to a table, we don't have time to do this. I apologize, it's taking a little longer than I was hoping. But when you make your first connection, you will be able to, it's not opening up. In the status bar, you'll see that there's a link to make changes to this model. And that is the trick to convert your data model, this local data model, into a new Gen 2 composite model. It allows you to create direct query connections. And then and I keep wanting to use the word import because that's what we normally do, but I'm not importing anything. I'm simply referencing a connection, and then I get all of the tables. You see all the blue tables? Those are from my online sales data set, and my red tables are from the store sales data set. And I have some redundancies out here. And you can't delete tables, but I've just hidden these tables because I don't need them. No overhead because I'm not storing any data. There's absolutely no data in this data model. And here you can see, oops, here you can see that I have an error because I opened the wrong one. All right, we are right at the end of our time, so let me go ahead and talk about that. So this really is having your cake and eating it too. It's something that we've been waiting for a very, very long time. This, the product team have been talking internally about this for about 3 years now. It's been a huge development effort. It's now in public preview, which means it's going to be a while before it's in production, but it's something that we can all play with, we can all work with. Use it at your own risk because, you know, I'm sure that there will be bug fixes, but it allows you to do some magical things now and provide some feedback to the Microsoft product teams. All right. Well, we are right at time, and so at this point, I will ask if there are any questions. And while we're waiting for questions, I will take you to the last slide here and just say, don't be a stranger. Please reach out, connect, participate in the community. There is a lot out there. I was kind of promoting my personal blog a little earlier, and I'll just point out a couple of things. This is something I do in my free time. I've been doing it for a very long time. I had about 1.4 million views on my blog since 2009, I think 2011. But something that I've recently added is a resource page, and these essentially are the people who I trust in the community. When I have questions, when I need help, these are the people that I go to. And so I would encourage you to use this page and follow this to become familiar with the work of all of these people who have active blogs, who write books, and participate in the community, and get out there and not only ask questions, but go out to forums and answer questions. Participate, be involved. That's what I do. That's what I've been doing, and I just absolutely love to not only use this product, but I also just love to just associate with people who are trying to solve interesting problems with it. So with that, Crystal, I will turn the time over to you and ask once again if you have questions, and but we'll go ahead and officially wrap up. So I thank you for your time and your attention today.
Hey, Paul. Yeah, you do have a few questions here, and I know it's already 12:02, so we'll try to roll through these pretty quickly. Let me start with the first one. The first one says, from Amy, would I need to create this twice for multiple dates? Example, various pipeline dates.
If I understand the question, the answer I believe is yes. If you have, let's say, a number of different events that are tracked in a table, and you want to do calculations, over those events. In this case, we were looking at order date, compared to the delivery date. Yes, you could create another measure that, let's say, calculated the difference between, I don't know, I'm kind of fishing for an example that makes sense, but yes, specifically you create a measure to answer a specific question. But we can also kind of get creative and do some more dynamic things. So without getting into the weeds, it's probably difficult to dissect that, but I'm going to give that a conditional yes.
All right, the next question is, can you talk through the risk of opening the cross-filter direction to both opinion to achieve cascading parameters from multiple different DIM tables? Can you give an example of how to achieve without switching to both directions?
Write a measure. As I said, the purpose of relationships in a data model is to tame your data. It's to take chaos and turn it into order. In doing that, you also create restrictions, limitations, and that's why we have, naturally we have one-to-many with single direction filters. So there are a couple different ways that you can achieve things like cascading slicers or cascading filters. And let's talk about what that means real quickly. Let's say that I have a a product category table, and I have a product table. Every product has a category, but a category can apply to multiple products. And so, we want to be able to select one and filter the other, and select one over here and filter this one as well. And let's say that there is a significant performance penalty by doing that. One way that I have worked around that, rather than using bi-directional filters, is I go create a measure that uses something like a treat as to get a count of records in the other table. And then I can filter a visual based on that count. So I'm filtering a visual. It could be a slicer, or it just could be another chart or some type of visual. I'm filtering that based on a calculation rather than relying on the relationship to do the filtering. That's not a quick demo kind of thing, but I think that if I can boil the answer down into something simple, it's that if you can't do it with a relationship, there's a good possibility that you can do it using a creative measure, using some DAX.
All right, we're going to take probably about 2 more questions here, and then we're going to go ahead and wrap up. It says, we generally solve these types of census problems by actually generating 1 record per day, then not needing the fancy DAX. Also performs better, often doesn't take much more space because repeating data compresses so well. I'm not sure if that was a question.
I completely understand the context of the statement, and I absolutely agree with you. You know, I'm a big believer in the work of these people, of the Kimball group. Now, this is a 25-year-old book, but you know, the Kimball Method says, take the business problem, whiteboard the whole thing, understand all of your business requirements, and in that, understand what the granularity of your reporting analysis should be. And let's say that we decide that it's daily. You know, we've got orders that are down to the hour, down to the minute. Is it important to know those? Is it important to know if there were 3 orders placed by a customer on a given day? Do we need to have 3 records? Or is 1 record that says this customer placed 3 orders on this day sufficient enough? So what I'm saying is I absolutely agree with what you're saying. Figure out how low you need to do you need to go to satisfy your reporting requirements and model to that level of grain. Now, it's easy to talk ourselves into giving more, to doing more. And I find this with consulting customers all the time. You know, do you need it down to the month or do you need it down to the day? Well, we only need it to the month right now, but I would imagine that maybe it would be helpful to be able to go down to the day or down to the minute or down to the second. Well, if you don't have a requirement for that, don't do it. You can build another table later, you can enhance your model later, but it's a balancing act. So yes, I absolutely agree with what you're saying. Shall we take one more?
We'll do one more. We'll do a simple one here. It says the PBIX file which you're using, Paul, will that be available for download for them?
So I've done this presentation, earlier forms of this presentation, and I have hosted, this is not exactly the same file, but you know, for example, the examples with direct query, it's really hard to share that because it's connected to my SQL Server database. But the answer to your question is yes, and if you go to my blog, go to presentations, here you will see an earlier version of a presentation on this topic, and you can download the PBIX files here.
Awesome, great. It looks like someone's asking a quick question. Any recommendations for a good book about Power BI?
I'm glad you asked. Yeah, I have several actually. Oh shoot, I just closed the page that I was showing you. My bad. I didn't realize that this was the thumbnail. So on the same page that I was just showing you, you know, when I think about expertise, I think about people. You know, there are people who I trust, and a lot of those people write books. And the books that they write are right here. So just down to the bottom of this page, these are the books I would recommend for beginners. Now they're, you know, depending on where you are, you know, if you're a business person who kind of, you know, uses Excel to solve a lot of your problems, then, you know, I would recommend this book by Matt Allington. If you're a data professional and you're in the weeds and, you know, you already have quite a bit of experience, then I would may not start with, but I would pick up, sorry, I'm having trouble finding the Italian's other book. You know, this book, Definitive Guide to DAX, and then the other data modeling books by the Italians. You know, so it really depends and you know, kind of where you are and what your focus is. But this created this page specifically to answer that question.
Awesome. Paul, if you're up to it, somebody's kind of looks like they really want to ask this question. Do you have time for just one more?
I have plenty of time, Crystal.
Okay, perfect. It says, can normalization of tables in a star schema go too far? I have a sales header table with many sales lines, and sales lines in turn have many discounts. Customers want to filter sales by discount types. I like to collapse into one big star fact table, but then have to allocate partial sale units and dollars and order numbers to each row. Some think that's too complicated and want to keep a high size relationship from, sorry, hold on, it's cutting me.
So I understand the context of the question. And first of all, as soon as you started asking, when we got to that first question mark was, can it get too complex? Absolutely. It is so easy to go too far. Dimensional modeling is a trade-off. You cannot create one model to answer all possible questions. And as you're sitting with the business and saying, hey, we're going to create this data model based on this data, and what are your requirements? I've never been able to sit with a consulting customer and have them give me 15 report requirements and say, here are 15 well-articulated, complete requirements that encompass everything that we absolutely need and that we will need nothing else. That does not ever happen. And so you have to step back and weigh, apply the 80-20 rule, and maybe it's the 90-10 rule to say, all right, how much do we include in this model that is going to be performant, easy to use, provide, if we are providing self-service reporting capabilities, you have to keep it simple enough that someone can actually explore your data model and be able to navigate it, as opposed to answering all those really super complex questions with arguably some performance trade-offs. That's a very difficult equation. And I know that I'm oversimplifying because these are complicated questions and complicated problems. You have to start small and work up, and you have to do it in iterations. You have to think about, if I summarize to the month, or if I summarize to a certain level of detail without providing the detail that I think this user might need in the future, am I cutting my legs off? Would I have to go back to the drawing board and redesign a new model? To some point, that's inevitable. And you have to think about the iron triangle of, I've only have so much time and so much money and so many people to provide a certain number of features. And so maybe we build a model that meets the need for the next 3 months, for the next 6 months, and we know that it doesn't answer these questions. But if we were to try to provide all of that functionality right now, it would be too much and we wouldn't be able to deliver a functional model. I think that the next generation of composite models is going to help us move that needle forward so that we can start simple and then start piling on. But we now just got bigger tools, which means that we're going to be able to make a bigger mess. So, this is why I love this industry, because there are always problems to solve, and the answers aren't always easy. I hope that answered your question enough to be able to say, yeah, I get it. But there's a lot of job security in this equation. Apparently I have a meeting in 15 minutes, Crystal.
But that's okay. We're going to go ahead and close out, you guys. Thank you guys so much for tuning in today on Tuesday for the webinar. We hope to see you guys next week for the next webinar. And like Paul said before, if you guys have any questions or comments or concerns, please feel free to reach out to him or myself. Also, you guys will receive an email with the webinar link in your email box around noon Eastern Standard Time tomorrow. Like I said before, if you guys have any questions, please feel free to reach out I cannot talk today.
That's
Please
all
feel
right.
free to
reach out, please. We're happy to connect with you, and if we can do business together in the future, we're happy to do that as well.
Thank you guys so much. I hope you guys have a good rest of your Tuesday. Paul, thank you so much again for hosting. We appreciate it.
Thank you. Bye-bye.
Bye-bye.